name is Mike Cousins. I'm the GIS Practice Leader here at OHM Advisors. As the director of all of our GIS operations, I oversee 11 different staff members, varying in experience levels from right out of college to many-year tenured employees. And my role at OHM is to not only oversee our staff and what we're doing, but meeting with our clients, whether it's a city, village, township, county, the state, private firms. I'm an extension of their staff where I can help them with their GIS efforts, whether it's mapping out their utilities, their water, sewer, storm, utilities underground, or crime mapping, crime analysis, to terrain modeling. We do a lot of basically any kind of GIS that a community would need. We're here to help them and support them, whether it's printed maps or online maps or apps, story maps. We kind of do everything. We fly drones, we use innovative technologies. We're a consulting firm with many disciplines. We have architects, engineers, planners, surveyors, environmental, water resource engineers, we have botanists, we have construction staff, and CAD staff, and we have a really large GIS group. OHM is a consulting firm, so we work with a lot of governmental agencies, cities, villages, townships, counties, state, federal, and a lot of private firms. We're a one-stop shop for engineering or design or planning or map making, where we can help our clients out with really whatever they need. I have a passion for criminal justice, and one of the cooler projects that I worked on was doing an assessment for a community to map out all the crime, both serious crime, code enforcement violations, minor crime violations, to help them and their police force to strategically improve the community. That was really fun. Do a lot of emergency response, emergency management. So after a lot of big flooding events, Midland County last year, after all the big floods rolled through there, we dispatched up there to map out all the damage and do assessments on all the property, trails, roads. And using GIS was the centralized piece that tied everything together. All the different agencies that were responding, trying to mend the situation for the residents as fast as possible. We deployed a lot of tablets and GPS units and camera systems and drones to go out there and assess everything so our engineers in the back end could start rehabbing the process right away. Enjoy that. Working with our planning groups, architecture groups, we can take a lot of their models and things that they're proposing, whether it's a streetscape or a new building or development. We can take their models and their plans and pull it into the GIS and overlay it on top of a topographic surface or aerial imagery, and overlay a lot of different GIS features into there. And then using some of our smart technology, I can visualize those designs and show it to the client in a more meaningful way than just simple 2D images or a video fly-through. So GIS can help with every one of our industries here at OHM. Traditionally, GIS is done on your computer using ArcGIS Desktop, ArcMap, or ArcGIS Pro, or ArcGIS Online, or our Enterprise, which has many servers and portals and whatnot. But in addition to that, I like to map our spaces out differently and looking for new innovative approaches to come up with a solution to our problem at hand. So whether it's deploying tablets and GPS units out in the field or working with our drone fleet, we have many different drones with many different sensors. We have a couple different examples. One example, with a lot of DOT, Department of Transportation organizations, we're looking at ways to improve our roads. And we started using drones with our infrared sensors, where we'll fly a road corridor, and using your infrared, it has a different heat signature depending on what you're looking at. So for locating potholes, for example, We can fly the drone and collect all our topo information and everything, but if we attach an infrared sensor on it, an IR sensor, we can look at the road surface and look for hot and cold zones. So with a road, sometimes the top layer will delaminate from the bottom layer, and it creates a void underneath the surface, and because water percolated down and kind of ate away that, and over time that road surface is going to collapse, creating a pothole. So looking at an infrared signature, we can look for cold zones in the road basically to signify where a potential pothole might be. And then we can send crews there to diagnose and check it in more of a manual way, traditional way. But this has helped us expedite the process and have much more efficient and accurate results. In addition to projects like this, taking a drone, we'll fly a drone over a construction site maybe before we're going to dig to see wetlands or soils or the topography of the surface, and we can 3D LiDAR map that out to give us a full depiction of what's there. So we'll fly before and after those big flooding events we had, wherever there's big blowouts or bridges taken out. We can fly that site and see how much volume of earth was removed, see the road profile and elevation, so our engineers know how to design and put it back basically. We do a lot of 360 imaging, so think of Google Street View, but for a building or a space outside of the main road corridor. So we map a lot of facilities or trails with that. I mentioned earlier about architecture planning. We take a lot of their models and load them onto Oculus devices. The newest one is the Quest 2. It's a lot of fun. That's virtual reality. We do augmented reality with Microsoft HoloLens. The difference between virtual reality and augmented reality is virtual reality, devices like this, or there's many different ones. What this does is allow you to see your space in a synthetic environment. So you're just seeing what the models and designs that you loaded onto here show. With the augmented reality, what you can do is it overlays the synthetic environment on the real world. So you're mixing technology with the real world, also known as mixed reality. And for our applications, whether it's a building model that we want to visualize floating on top of this table at a 1:20 scale, or if we go out into the open field and we show the city hall at a 1:1 scale, you can actually walk around the facility or walk through it and see what it would be built as if it was really there. Other applications we use it for, augmented reality is on new tablets, all new tablets and phones. So if we load our GIS of our underground infrastructure, whether it's our water pipes or sewer pipes, storm pipes, anything like that, I can actually visualize that underground using my tablet. When it's paired with a GPS with high precision, where you have a good coordinate location, as you walk around with your device or with the HoloLens on your head, you can see the pipes as if they were really there, if they were exposed within a trench. So this is very helpful for municipalities or anybody that's about to dig in the ground, so they can see what's there before they dig. So this is really changing the way a lot of organizations operate, and being hands-free, it's a lot safer and a lot more accurate. So using technology like this is very helpful. We've developed camera systems like this, where I take a tripod, we have a 3D printer, custom print to hold the GoPro system, where we will drive a corridor, a road, or a trail maybe that we're working on to show before. And then afterwards we'll come back through and drive it again. I've mounted this on top of a truck, a golf cart, an ATV. I mounted it to a bike. There's a lot of different ways you can mount this depending on the terrain and where you're wanting to go. But doing it before and after helps residents in the local community see the development that's going on, see the progress that we're working, and it also helps our engineering staff evaluate a scene maybe before or after, depending on the application. There's a lot more pieces of technology that we have, but using technology to map your spaces differently has really been a fun, enjoyable experience, where you can kind of think outside the box to come up with a solution to your problem. So I went to Michigan State University, go green. I got my bachelor's in geography with a specialization in spatial information processing. This was before their GIS degree was established. And really built my foundation, my knowledge for what GIS is and what it can do, and And then from there I moved down to Florida, worked at a consulting firm down there, focusing on stormwater management and a lot of geologic principles. And then after that, I left and went to work for the DoD on a contract for the U.S. Army, where we built real-world simulators for the troops to train on. It was completely different than my previous experience. I learned a lot and made a lot of really good connections, and then left there, came back here to OHM, and I am here. As far as education goes, I'm constantly learning and developing new skills along the way. You never stop learning in this industry. Everything's constantly changing and evolving and getting better. What we were doing 5-10 years ago is completely different than what we're doing now, and it's going to be completely different in a few more years. First off, GIS as a whole, principles of GIS, are found in pretty much every industry, from healthcare to law enforcement to engineering, architecture, planning, surveying, construction. GIS is used in some facet or another. Retail is another example. Whenever you go to a grocery store or go to the mall, everything is strategically mapped out for a reason. The same thing with hospitals. Every space, from the emergency room to the elevators to the check-in desk to the rooms to the x-ray room, everything's been mapped out spatially to be as fast and efficient as possible. No matter what industry you're going into, GIS is relevant in one way or another. Having these GIS skills and knowledge will benefit you long-term in your career, whether you know it or not. And having this as a skill, if you go through the schooling, and whether or not you continue education post high school or not, it makes you more valuable as an asset to a company if you have this knowledge. So get in it, experience it, and it might not be for everybody, but if you have that built-in foundation, it's going to help you succeed long-term in your career. To me, the biggest skill is willing to ask questions. You have to ask questions no matter what level you are, from entry level to director level like myself. I'm always asking questions. If I don't know it and I can't figure out within 5-10 minutes, I'm asking somebody else if they might know it. There's never a dumb question, and that is very, very true. Usually early on in careers, people don't like asking questions because it makes them look weak or whatever. That's not the case. I'd rather you ask 1,000 questions and let me help you out versus you spinning your wheels for an hour, 2 hours plus, because there might be a simple solution that we've already figured out and then we can assist you. So asking questions is very, very key. And when you're asking for direction, absorbing that information in your brain, not just going in one ear and out the other. Think of what's being explained to you. Take notes and take a step back after you're done and realize what you did so that you can absorb that for the next time something comes in, and you can tie back to what you did 2, 5, 10 years ago, where it can help you solve a problem in the future.